today's Kubernetes Auto Scaling. This is a good book because was written by a person that I know that works in enterprise environment. I have experience with customers, right? And we see a lot of the field questions and problems and corner cases. So it's awesome that you dedicated time to read this, and it covers things like Karpenter, Autoscaler, Cluster Autoscaler, KEDA, HPA, VPA. It's good that you included KEDA. It's the one that I recommend in certain circumstances. So it's good that the book covers that. So I even got ping in LinkedIn people saying that this is a great book. I think Daryl and some other folks in LinkedIn were mentioning that.
Hey, Carlos, how many sessions we are planning for this book?
So it depends how much we cover or the team wants to cover. But I think we're going to do the first two. The third
Okay.
week we are pausing for two reasons. And that's part. Let me see. Around May, yeah, the April 30, May 1st, we are migrating. That's part of the news here, and then we can continue. Maybe two more. It depends how much we want to
Okay.
cover in auto scaling. It's always like the interest of the group. Um, and the book has a lot of detail hands on, so it's not very superficial. So we can, and Christian have like very nice. Agree to show some of these demos running at some point. I don't know if you're ready today or not, but it'll be good to just show it. Okay, cool. So with that, let's start with Christian. There's an introduction. Like, tell us a little bit about yourself, and then why you took the task to write this book.
Sure. Thank you, Carlos. Thanks for having me. This is very exciting. Um, I'm a specialist solutions architect for compute in AWS. What does that mean is that I help customers to make the most of EC2 capacity. I don't think that is a surprise for anyone, but most of I would say that 99% of my conversations with customers are around Kubernetes. And since we launched Karpenter, I started to get involved into these conversations with customers, how to make the most of it. Throughout this journey, I have helped several customers to adopt this technology, specifically for Carpenter, and most recently with KEDA as well. I've seen customers public references, for example, like Ryanair, where they actually adopted Carpenter Spot, KEDA, and they were able to get 70% discount on the EC2 spend that they had on daily basis. Stories like that. I have a lot of stories to share with customers, pain points around migration, pain points around upgrades, and how Carpenter started with a cost optimization project, and then it actually helped them to make a better use of the resources that they had, make the cluster more efficient. And so that's partially why I started writing this book. It took me 1 year. I thought that I talked
Wow.
on daily basis with customers about Carpenter, so it should be easy to finish a book. But if I could go back, I would tell myself you're completely wrong about it. It would take some time because you go through the process of thinking about it, the outline, planning the content, make sure that it connects, that everything connects to it. I was planning also on making the book very hands-on, so it took me some time to build the labs to make sure that it worked, that it won't break. So the idea was basically to help other customers, other people, new people learning how to make the most of the cluster. And that was basically the plan: how to help others to make the most of Kubernetes Auto Scaling, letting them to have some time to digest everything that we have read around blog posts, conferences, and structuring in a way that I can guide you on from starting to knowing only Kubernetes and hearing about autoscaling to actually become an expert. Maybe not an expert. No one is gonna be end up being an expert unless you're up to date with all of the changes. But yeah, being very proficient with Karpenter and KEDA as well, not just on how to use it, but how to make the most of it. And I really like that. I was uh, accompanied by other contributors from these two projects, as these developers contributing to the project, helping me to review, giving me their honest feedback and improvements. And yeah, so that's why it took so much time to write the book, because it's not only something that you will write from like a blog post. It actually takes a lot of time. So yeah, that's basically it.
Yeah, and it serves as a reference. Even like it could be a short course that somebody can take in a right in a people from universities attend these sessions, so they can even like uh take it as a reference book, right? And even myself, right, can go
Mhm.
back and as a reference. We'll get to a point, or maybe we can discuss a little bit here, and then we'll discuss it later. Is how you felt when you finished the book, and then in place pod resizes came out, and then now VPA can do that of like even to the point of putting higher requests at the beginning, and then after a while a factor like, oh my god, I put that in ink.
Yeah, no, actually, I knew about it because you know how the release process of Kubernetes
Yeah, it takes a
works.
long time.
There's when I was writing the book, those features were in alpha, I think. So I knew about them. So there's a note. I knew about it. So there are a few notes about them in the book.
Yeah, but it's not something that like an example or like use this in production, but
Yeah,
today we
exactly.
can, right?
Yeah, yeah,
But down
exactly. There are a few
like
features that when I was writing the book, not only that, not only just that, features from KEDA and Karpenter that were in alpha.
through the yeah, and we can
Yeah,
also discuss. That's the good thing about this book, right? Like a book club of like we'll discuss the book, but it's the book is more of a topic, right? And then we can talk about like the latest things that are like valid now with the latest versions of
exactly.
all these projects, because these projects evolve after a while, right? What was supported in when you wrote the book is not supported now, or maybe new things are supported.
Yeah,
Okay. Any
yeah.
questions from the team or the folks so far? And Christian, you are located where? Where do you live?
I'm based in London.
Oh, yeah, and you put that in there in here.
Yeah,
But you moved. You were living somewhere else, right? And then you move.
yeah. Just to live. Well, I'm originally from Guatemala. Um,
Okay.
uh, yeah. Those who don't know, it's the country right next to Mexico. We speak Spanish there, and it's very similar in food, in culture to Mexico as well. And I also love Mexican food as well. 7 years ago, 8 years ago, I moved to Spain. So most of my time in Europe or in this side of the world, I've been on living in Spain. And last year, I moved to London.
Right. Right. I would stay in Spain. I like Spain a lot. Well, at least when I travel there. But yeah, London is also good. Yeah. Uh, Easier transportation than the US. I would say that's the biggest difference. You can get
Yeah.
anywhere very easily to train or public transportation. I live in
I
North
would say
Carolina, and there's
it's not.
nothing like that.
Yeah,
Sorry?
but although I would say that is not the most the cheapest way of transport in Europe. It's very expensive. Train is very expensive here.
Okay. I have the book up. Here's a couple of layout of the book. Right. The first one I started with the first chapters, and then I sneak sneak peek in the other one. So it looks like you start right, because it's KEDA, VPA, and HPA, but it's like I think so far what I saw was you didn't took an approach of like, let's take a whole chapter and then from HPA from the beginning to end. I think the first ones you mentioned them to be aware of what they do, and then the other chapters go deeper. Is that
Yeah.
correct? That's what I saw from like starting the book.
Yeah, exactly. I wanted to, for if you were new to all of this, to kind of like try to put in place all of the acronyms that you might have heard about Kubernetes Auto Scaling and know what they are, and then I will go deeper. Kind of like, if you think about it, it's kind of like what I've seen customers using and how they've been moving on their adoption phase. Usually, even though I don't think that I'm saying anything new here, but people don't go and implement KEDA and Karpenter in one day. Even with AI right now, I think it will be impossible to go and do something production ready. So it takes a journey on doing all of this. So that's basically my aim, to start from the basics, talk about it, and then going a little bit deeper and deeper and deeper as you progress.
Yeah, and I like, for example, I started reading the Workload chapter 2, which was the workload, and it also mentions KEDA a little bit, and it's like, is this it? And then chapter like HPA and this, but then chapter part 4, then it went into KEDA, deeply into KEDA, and I think KEDA is kind of like the flexibility of, right, like it's not, the first two were like very static. They have not changed that much since they got there, but you needed to have all the signals, right, to match your type of workload or traffic or timing also. Like I see, I have a story of a customer that were trying to scale based on time, right? They have these football games that they sell a lot of tickets and that doesn't happen every day, but they needed to do it in a certain schedule. So it's not just like it can also be predictive, but you cannot put a time in an HPA, right? Like a cron job. I think that for the eons from the beginning of, I've seen that request of like, hey, can the HPA have a schedule?
Yeah.
And that never happened. But you can implement that outside with KEDA.
Yeah, exactly. The reason specifically to this, why I started with HPA, it's because KEDA is we can go over it later in more detail, but KEDA is basically an abstraction that goes on top of HPA. It uses HPA, so it's important that you understand how it works well, and what you're capable of doing it. I will say that at some extent you can replicate or try to do most of what KEDA does with HPA. The difference will be that it will take you too much time and all the boilerplate that you will need to code. It's abstracted by KEDA in a very good way, in a pluggable way, so to speak.
I have a question from Satish. Can you ask the question? I'm not understanding the question. How to estimate spend on-prem?
Yeah, if customer is on-prem, it's all VMs, right? Now they want to migrate to Kubernetes, right? Maybe cloud provider, right? And they use Karpenter, KEDA, or whatever, right? How do you estimate the cost? How much it costs to run in a cloud provider? Like, any thoughts?
Yeah, so in that case, what we've done, actually did a few times this exercise with a customer, because it can get complicated very fast, and the idea was to just make an estimation. was to run simulate a small footprint of what you have in on premises. Run it on, for example, in AWS with Karpenter KEDA, and try to simulate a simple workflow, and we can get an estimate of cost. Either we, for example, for AWS, we have tools to get kind of like estimation of it. Now with AI, you can get that with very easily, so that you can get a kind of like a snapshot of what your workload would look like, and simulate a scaling event, for example, and get a good estimate. That's the most uh, I wouldn't say reliable, but the closer that we could get to an estimation. Because otherwise, what would you typically do is kind of like have a spreadsheet with the prices from the calculator for the cloud provider and try to estimate. But we wanted to go further, because actually it was very a good exercise to know it a smaller footprint, how much will it cost to run something live into a cluster, right? So yeah, that's
So
basically what.
yeah, Christian, if don't want to do all this work like deploying and seeing what it does, right? Is it just good rule of thumb? Just look at how many VMs, memory, CPU is allocated, and estimate similar in Kubernetes. Just rough estimate.
The key point here is that you can go through that as well, like saying like, hey, I'm gonna estimate how much capacity I'm gonna need, and then use the calculators. But the key thing here, and I think that I emphasize that in the book, primarily in the first chapters, that your workloads you need to know how much requests your pods need. Once you have that, you can estimate that. So say, for example, you will need one CPU, two CPUs, or half of a CPU for a workload. Then it's easier to not just to scale, but to estimate. So yeah, once you have that, once you are aware of that, you can easily get an estimate based on exactly what you were saying, the type of VMs, instances that we have in the cloud provider, and try to estimate how much load we will need depending on the traffic.
Like, for example, there is one CPU, right? And give me an example with traffic and how would you estimate it?
Yes, exactly. Yeah, yeah.
How,
Yeah,
how
yeah.
would you do it? I'm asking. Like,
Satish, I think we need to go to the book, Satish.
okay, okay,
Versus a consulting session. We'll
okay.
charge you, Satish, per hour on transferring your VM from on-prem to the cloud. But I think this book would teach you also about, and then Christian did that a good job at the beginning of the book, and then we can get into that, like the utilization, right? Maybe those on-prem servers are capex, right, and they're not fully utilized. So the first investigation is, are they being used or not? Utilization, because you can, and then people have done a great job on premise. You can still have a great job on premise, like we have EKS hybrid, and you have VMs, and they're highly utilized. And utilization comes from like the workload estimation, like how much the workload would use, or your estimate is going to use, and then how to make replicas in and out, right? Scale out or scale in. I learned that at the beginning when I started with Kubernetes. You don't scale up, scale out and in. So great question. And then that is related to the book, Hatish. Like utilization, I think is the key to storing to do that, because in the cloud it's an OpEx, right? You can like delete the cost just by deleting things. In the on premise in your building, those servers stay there for a long time. So let's go over the first beginning just for intros. I think looking for the you explain, and also this book is not like you use AWS and EC2 as an example, but everything in the book is applicable to other cloud providers, and even like a lot of portion is applicable even if you're running on-prem, like we were talking, right? Like if you're running on-prem and you check that these VMs are being created in the wrong size, right, and they're not utilized, it's because you're not using this type of tools. Even KEDA HPAs, you can use it on premises
Yeah,
to maximize the share of that hardware, right, between projects or line of business.
I agree. Yeah, yeah. I think that before we start, I actually said it in the book. Before you start working on the cluster autoscaler or Carpenter, you're free to use even your local cluster, because the idea will be just to understand how HPA works, how BPA works, uh, and how the other tools and observability works. Um, you do not need to have a cluster running on a cloud provider, for example. So the first half of the book, it's agnostic, I would say.
Yeah, yeah. I think you even like at one point you deploy a kind cluster. So
Yeah,
this
yeah,
this is the picture, right? That actually we were talking about, right? That you're over provisioning. You're creating that VM or buying that hardware. Like I think everybody uses VMs, right, on premise, and we're using that in the cloud. There's no need to do metal. And even recently, now we have nested virtualization. For those of you that are not aware, in AWS, we now have nested virtualization. And when I joined AWS, like, why do we have nested virtualization? That's a common thing. So now we have nested virtualization. Carpenter, I think, has a PR that's not merged, but
yeah,
you
yeah.
can set that with self-manage. Hopefully, we'll get it soon. To be abstracted, right, at the Carpenter level. But anyway, everybody carves that VM, right, or EC2 instance. We call them EC2 instance, and the idea is to get it uh, maximized, right? You're paying for that VM. Either you have one process or 15 or two. That the idea is to highly utilize that to minimize the numbers of those VMs that you need and minimize the cost. So that's the beginning of the journey right here. Um,
There's also the challenge of under provisioning, as you can see in that screen. You might be create a VM or an instance that the capacity that it offers is not going to be enough. So how do you make sure that you have the capacity that you need? Because in this case, in the image, you can see that you over provision because you needed more pods, and then you will end up with 3 pods not running, and that will have an issue in your performance as well.
but the essence, and we're going to see that with node scalers, right? That this is how it works. When it gets to a point that those pods don't fit here, they go into pending. So a no new VM gets created,
Yeah,
right?
yeah,
And they'll start landing there. So that's where you get the savings, right? And then when maybe traffic goes down, if it's an app that gets traffic and not doesn't get traffic, or it's a scheduler or a batch processing, right, processing um you know finance aspects task at the end of the month, right? There's a bunch of work that needs to be processed in a job way. But then the beginning of the month is like nothing, right? There's nothing running, so you have
yeah,
to scale in back. So the you explained the vertical auto scaling um, is moving to bigger VMs, and I think you mentioned like this is not practical to move the nodes, right, size.
yeah,
It's
yeah,
like they cannot just grow. That's why even to the bare metal, right, you have to size them correctly, because then it cannot grow in size. But then what you change is the amount of resources you dedicate to a container or a pod. um, and then this one is horizontal auto scaling, right? Adding more server. This is like the 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 one that is more practical, right, Christian? The horizontal. I think you mentioned that in the book. More practical, or maybe you start with this one, or this is how the best practice to start, and then the other ones are like, if this doesn't work, go to the other strategies.
yeah. It's also gonna be faster to add more servers rather than resizing one server or two. You might actually bring some downtime while you're doing that. So
Yeah, and you have it here. Scaling out. Um, so it's scale in and scale out
Yeah.
when you're
Hmm.
doing these type of things. I think you have something here. Um, yeah, you mentioned the control plane. I here, right? When you go to a cloud provider, can you talk a little bit about this? Like, what is the thing that you're going to worry about, and what's the thing that you're not going to worry about?
Yeah, so basically what I wanted to do with this section is to make sure that throughout the whole book we speak the same language, and we refer to when I refer to the control plane or when I refer to the data plane, readers will know what I'm referring to. And the other reason is to simply say like, hey, we're gonna focus on the data plane scaling, because usually on the control plane, you might be running this in a cloud provider, they will take care of it. And if you're running this on premises, um, it's not that dynamic, that you or is that the scaling part is not going to be as frequent as the data plane, and usually it's protected from scaling or scheduling pods over there, unless it's something related to the control plane. So that's why I wanted to just to I know that even if you go to the Kubernetes docs, you will see a more comprehensive diagram of the Kubernetes architecture, but I just wanted to keep it simple to say, like, hey, we're going to focus on the data plane and how to add more capacity to your workloads.
Yeah, and the control plane are things like the Kube API, the scheduler controller, controller manager. Um, like when you run a kind cluster, basically there's a few pods, right, that are running. These are the ones that are running the control plane. You don't have to run it on every node. Just one copy of it. And one aspect of the control plane, and talking about like in terms of like home labs, if you want, usually that people deploy the control plane like in 3 nodes to have like the minimum quorum for etcd, right? But in if you have the home lab or have physical servers, you may think that you may be wasting the whole uh, computer in a control plane node. But one aspect of Kubernetes is very flexible, that you can run multiple control planes in those three computers. You don't have to use the whole. You can run two Kube API servers, for example, in a computer. Something that when I started learning Kubernetes, I thought that was like kind of like a one Kube API. Like I didn't understand the in and outs of it, but it's how much you dedicate to it. Even to an extent, I did experiments that even the data plane, you can share it, right? You can carve it and have two kubelets and two container Ds and all those things. But it's like these like kind of like home labs, like experiments. You don't want to, if something goes wrong with one, it destroys the other one. But they're very flexible. Once you learn the in and outs of this, you get a picture for that. And the control plane is something that is fixed, and then the data plane is what costs most, right? Like when end users see their bill from the cloud provider, control plane is kind of like a fixed thing that is per hour, and then a month you actually see the same billing. But the one that charges is that line that you were mentioning, that EC2 node line in the bill. That this is the one that you want to like that dramatically keep down in cost.
Yeah, yeah,
Let's see. It's still in chapter 1. Um, yeah, and workloads. This is where we start seeing like the pods, right? The units of pods on the more replicas, right? And 60. I'm too confused about the 80% and 65% here.
All right. So basically, first of all, what I wanted to do is, because typically this comes as a way that I've been talking about Karpenter, for example, or Kubernetes Auto Scaling. Usually, what I did into the session is that, hey, you need to understand what Kubernetes Auto Scaling is, and it's basically divided into two spectrums or categories. One is going to be the data plane, and another one is going to be the workloads. So we already talked about the data planes and what does that mean and the workload. in this case, what I'm showing here is that for those specific pods, when you reach out that 80% of CPU utilization for those 3 pods, you need more capacity. So when you add more pods into your deployment, for example, you end up having 65% of CPU utilization because now the load is spread between these pods.
Yeah, yeah. I think later we'll see the calculation on that. So it's the average
Yeah,
on these spots. And the interesting part is like if you use the HPA, right? It's an average regardless. Is one of them is 80% and the other one is 20%, right? Because it could be
yeah,
that the usually that when people come into this Kubernetes stuff, they think about web traffic, like websites, right? And then you say I have 100 users and they're split into 3 pods equally. So if I do the average, right, it would be 80. But the pods could be doing something, taking jobs from Kafka, right, or from some queue, and one
yeah,
is super busy because the topic is hot and the other one is not, those consumers, right?
yeah,
And that's where like HPA, if you do the average, right? You may need something else, or maybe that's something that you need to maybe separate into deployments. I've seen that, like the one deployment for one topic, one deployment for the other, so you make the HPA work. Like HPA may not work, but you may need to do something else, right? But it's the average. Like you're assuming that they're equally or semi-equally busy.
yes, yes, exactly. Yeah, it's gonna be using an average on the CPU and memory metrics, taken from the metrics server. That's another component that you will need to enter your cluster before you can start.
Yeah, and this is the way of like as they come in, they get starting spread, like assuming like this node can only take four pods, right? It's full, so you have you have space to fit 2 more pods of this in here, as long you set the requests. And that's kind of like the 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 biggest problem, that people don't know what to put for request or guessing. And I think you have an approach on the next chapter. We'll talk about that. Guessing is not a strategy, right?
Yes, yes, it's not. It's not at all.
And sometimes it's not obvious sometimes is I've seen in situations that sometimes is easy to know that like the workload is not that unpredictable, right? So it's a matter of like monitoring, like, well, how much is consuming the thing in the last 2 weeks.
Yeah,
And probably if you have never you set monitoring, probably for the rest of the year will be the same consumption, right? And that's good enough. And it's just like they didn't know to measure it first, right? They think it's like another magic because it's Kubernetes or doing the Kubernetes way, and it's not that different from like a process, right?
yeah, yeah, yeah,
I don't know
yeah.
if you have seen that before, but
So
I started
usually,
like mentioning because it to me was obvious, but maybe for the end user was not obvious, and I got surprised once, so now I mention it just to be safe.
no, yeah. I mean, you're completely right. What I've seen, and actually, um, before joining AWS, I used to be working on a company where developers were just changing that constantly because it stopped working. The apps were not working, and in the past we just added a larger machine. Now developers just change the number of requests and like, hey, okay, I need more CPU, and that's it, and that fixed the problem. But in reality, we know that that didn't fix the problem, right? But yeah, seeing a lot of patterns, anti-patterns as well, like that, trying to guess how much request this is gonna need, and that's actually what I'm going to cover later in this book. How to start simple and try to not just get an estimated guess, but using data, exactly as you were saying
Yeah,
before.
yeah. And so like I said, it's always a journey, because it's not just Some folks may assume it's just configuration YAML files that is the fix, and sometimes it's the application, right? For example, they will say, well, what about if I have a lot of users coming in and I need more memory and more CPU? And you say, well, the thing will create another copy, so those extra people will go over there, or but then they say like, well, but the users were already using the first servers, and we have session in the pod, right? And like, what session do they need to land in the same pod? They cannot land in the fresh pod. Why? And then that's you start uncovering that they didn't refactor the app. They moved the app from a legacy, right, monolith or something like that. They didn't refactor the app to say, no, you use something like Redis or KV Store, and if it lands in another pod, if you need state, you grab it from there fast enough to where you were in the middle of a session or something. You pick up the session in that other pod and continue, so the other pod can die. And it needs to refactor on the app. You cannot just fix it with YAML files. I don't know if you've seen that.
Yeah, and sometimes it's not only about that. Sometimes the applications, that happens to me a lot. CPU metrics were fine, memory metrics were constant, yet the applications were not working. Something else was going on, even though exactly as you were saying, maybe the spread was not evenly distributed within the pods that you had, and that might be another issue. So it's not something. Sometimes it's not just only about setting up the right metric, but it's a continuous process. So maybe the sad news for system administrators, platform engineers, and developers is that this is a continuous job. It's a continuous improvement job. That's why my aim is to show you kind of like the pattern of what to use and why it's important. Because, yeah, today it might be that you need one CPU. Tomorrow, the developer created a patch that now it requires less or more CPU. So it's constantly changing this.
Yeah, you mentioned another solution is the make the the spread evenly, right? Or the if you have like a transaction that is taking a long time, right? You don't want to set another one there. So the strategies in networking to say you do it based on latency, not round robin, right?
Exactly. Yeah.
And those type of things. So this one talks the introduction to Karpenter or CAS. CAS is for Cluster Auto Scaler. That's from the Kubernetes SIG, is the owner of that. Also, Karpenter is part of the Kubernetes SIG now, right? Both are
Mhm.
part of Kubernetes project. CNCF, there's no separate CNCF project for Karpenter. I was clicking in the wrong thing. And then the last chapter, which I was a little bit confused, you show how to create a kind cluster and a EKS cluster, and it ended. So I was kind of like, this is going to be used in the rest of the book.
Yes.
Oh, okay. So this is
Yes.
just like the mechanics to make sure that you can get a cluster created.
Exactly.
Um,
Exactly. So what I wanted for readers to be is to have is like in the first chapter, okay, you understand how it works, how the scaling works, what are the challenges, why we need it. Now let's start with something that we're gonna be using throughout the whole book, a Kubernetes cluster. And with that, I offer two options: one to using kind to run it locally, and the other is to create an AWS cluster. Again, like you were saying before, I just choose these two options, but it doesn't matter at this point of on time of the book. It doesn't matter how you have the cluster. Even if you have one already running, you can start using it. The idea was to show you how to start from a fresh cluster, and then say like, hey, if you specifically for AWS, if you're done for the day reading the book, make sure that you terminate the cluster,
yeah.
because when you're back, you're gonna need it again, but you don't want to pay for that while
Yeah,
you
that's
were
true.
not reading,
That's true.
right? So,
One thing that I'm going to point out, I don't know if you have an exercise in the book later, but a kind cluster. You can create a kind cluster with multiple worker nodes, so you can set like kind has a configuration file, like you can configure anything that you want, so you can even create like nodes with less memory, right, or less CPU to mimic that they land in here and they're full, so it lands in the other node, and you can see that. So you can create a multi-cluster with kinds. I think that didn't come up until recently, like for the eons. I was working with one node, and they added multi-cluster at one point. I think it was a few years ago. Well, I've been working with uh, Minikube first, and then in kind
Yeah.
for a while. So yeah, this is some similar what we were talking about, right? On the utilization and the requests coming in, and the error rate. And you mentioned something, right? That the CPU and memory utilization can be straight, and then there's
Yeah.
something wrong with the app.
Yes. Yeah. Um, Perhaps the main. I think that I start with this in this page. What I start doing is to try to make the reader aware that it's not only CPU and memory utilization. You might need other metrics. You might need to pay attention to other relevant metrics, even custom metrics that might be telling you that the application is working as expected or recent. Sometimes, like I was saying before, CPU memory looks fine, yet you have errors in your app. So
Yeah,
I start to address that or start to um, talk about it here.
yeah. Monitor all the things. Um, and then this is how explaining how the, and it's good, right? This is a book that is like doesn't assume that you're an expert on everything, right? I know that the few folks here are already experts in Kubernetes, so they know how it works. But the kube scheduler, right, it goes by the and kube scheduler default, like there's multiple,
Yeah.
for make people aware, there's multiple schedulers. You can install a scheduler in a cloud provider. Is a controller that it looks at the pods that are pending, and if they don't have a scheduler set, the name of the scheduler is default, so it uses the default. But there's schedulers that are based on the base scheduler, and then there's plugins that go on top, so you can like have your own logic of how you want to schedule these things, right? But the one that we're talking about is like taking the default one that uses things like, I don't know, uses like affinity, anti-affinity,
Yeah.
topology spread, checking which nodes have like still some resources left that you can fit a pod, and then at the end of the logic is like it sets the node into the pod, right? But have you seen people using sch- custom schedulers?
Yes, yes. I've seen people using other schedulers. So, for example, right now in what you were saying before, like by default, what it tries to look at where the pods fit, but sometimes that might not give you the efficiency that you want. So, what I've seen other customers is using a different strategy to say the scheduler to fit to kind of like do bin packing or try to put as many pods in one node, then go to the next one so that you can have maximum efficiency here. And now with AI, things are changing as well. You have other schedulers that are taking into consideration something else to schedule the pods based on different rules to make sure that agents or the GPU-based workloads are working efficiently. So there are other paradigms and other applications or use cases for schedulers, but I don't go into that very deep. I think I just mentioned that, but the main purpose of going into this is so that you are aware um, the importance of configuring the requests on the cluster. When you see later in the book, I say like, hey, we already know why how the default scheduler works, and how it's gonna schedule the pods into the nodes that the cluster has available. What will happen if you don't have requests configured into the cluster, into your pods? Well, the answer is very simple. The pods are gonna be the first candidates to be evicted, and if the cluster of the nodes are under pressure, the kubescaler is going to say like, hey, you don't even know how much how much requests you want or need. Get out. I have someone else that knows what it needs, and I need to schedule it here. So that's another kind of like trying to make sure that people is aware of the importance of that.
Oh, okay. So you're saying that in terms of like what's the name, the priority on the pods, like there's a setting that you can set, right? A
Yes.
priority, but one that is implicit, not explicit, is if there's a pod that sets the request that I need this amount of CPU or memory or either or, and then this pod says I'm YOLO, I don't care what I get, and there's pressure to take one out, right? The one that didn't specify request will go out.
Yes,
And it's
exactly.
an implicit thing, like it's not anywhere. Interesting. I learned something new today. Cool.
Yes, yes, yes.
um Another misconception that I've seen is with Karpenter, just to highlight how Karpenter and Kubescheduler work, is when you have a pod and starts with the first signal is the pod is pending, right? So the pod gets created and it's pending because the kube scheduler try to say, where can I fit this? And there's all the nodes are full, and the scheduler says like, I don't know how to create new nodes. Then that's the signal for Karpenter to take over, right? There's a pending pod that the scheduler cannot fit anywhere. I'm guessing it's based on timing, or I don't know. And then the schedule, but Karpenter doesn't place that pod in a specific node. The Carpenters looks like, what is the best possible node that I can create now based on everything, right? It's a big rule engine saying, not just looking at that single pod asking for one CPU, but it's like all the nodes are already in place, all their pods are in place, how they're like there, and then doing calculations of like, well, if I need to rebalance these things on this new node and delete some of the other nodes and like
Yeah.
maximize the efficiency, boom, this is the new node that gets created. But then kube scheduler goes around another thing, and then it's the one that places in that node, right? People think that Carpenter, after it creates the node, says, oh, let me set the
Yes.
pod in the node in the pod.
Yes, exactly. That's exactly right. You're going way too advanced into the chapters. That will be chapter 7.
Yeah.
Actually, but I get your point here that it's actually it makes it is very useful to understand where each of these tools fitting into the whole process. And yeah, I get that confusion a lot, that Carpenter is gonna do everything, but it knows it has its own responsibility in a single responsibility, and both Carpenter and Cluster Autoscaler will be triggered by having pending, or a better term will be on schedule pods.
Yeah. Requests and limits. What's the biggest confusion here on requests and limits that people have?
There is something that I've seen. Actually, now if you ask your favorite LLM model, based on the information that it gets from the internet, it's gonna be pretty common that you see a pod having different values for requests and limits. And as you can see in the picture, basically requests are what the kube scheduler uses to place the pods into a specific node. And the limits is a configuration that the kubelet uses to constrain or to protect other workloads running in the same node from being affected by a pod that is behaving or consuming a lot of resources. So it's kind of like a protection mechanism. But in Kubernetes Autoscaling, what it matters is the request that you have.
Yep.
You might have a pod that doesn't have a limit, and that will be completely fine, at least for autoscaling specifically. But yeah, the limits will be something that you will need at the application level. And I actually include a section on how to configure it and what are the best practices of using it. But the conclusion for this is just to make sure that you test your workload, because there are certain implications about you configuring one or another. But yeah, essentially that's the main difference between
The
these two.
biggest confusion that I see is that people think is limit is the size that is taken into account if the pod fits in that node or not. Like people will have like in this case, let's say that you have a um, a VM of 2 gigs, and they will say I'm sorry, they will say, "Oh, this pod would not fit there because it doesn't have don't have space to fit the 1.5. Already have one pod." Well, it will go in because the request is 1 gig. The limit is something afterwards when it's running, like you mentioned, that the container in the container D namespace is created with these limits of like CPU and memory. This Linux process cannot take more than the CPU and memory,
Mhm.
and if you're very busy and you have a lot of work CPU to work, you have to wait. It gets slow. But memory is worse. If you go beyond that memory, you're boom, right? OOM. That's what you get with that. Um, I think we are at a time, but I think we can pick it up in the last. I think this is the last section on the Prometheus to measure it, and then we can jump a little bit quicker in the next chapters next week. What do you think?
Yeah, sure. I mean, we can talk about the hands-on lab here, but essentially, what it does, it's gonna guide you on to deploying Grafana and Prometheus, because one of the first things that you need to know to stop guessing how many requests you want or need is to have observability in place, is to have something that tells you how much you need. And a good candidate for this is Grafana and Prometheus. And in the lab, what I show you is like, hey, just deploy this without any request, without any limits. Let's send a load test and let's see what the number you get from CPU utilization, and use that metric to configure that in your pod. This is what I was talking about before on the kind of like the approach or guidance that I've seen customers implementing, and it's something better than just guessing what the metric will be.
Yeah, exactly. Measuring just with Grafana or Prometheus, or you're in place. Question for Jamal before we leave. He said that 135 brought in the in place pod resize. Where does this fit in? I think we're going to cover that. That's what we're talking about at the beginning. I think we're going to cover that when we talk about probably VPA, right? The vertical, and also like apps like Java that take a lot of CPU at the beginning, and then they get stable. So thank you again, Christian, for attending. Thank you everyone for attending this session, and then we'll pick it up next week as we go deeper into more advanced topics. Today was just introduction to the book author, the book, and some of these concepts about requests and how they get scheduled. But we'll go into solutions next week. So pick up the book and read on it, and then we'll pick it up next week. Thank you so much, and I'll post
Thank you, everyone.
Thank you.
See you.